All right, so our next example, it says a farmer buys a tractor for $50,000. So if that's how much he initially bought it for, that is going to represent my A value. That's my initial value. Now, the key word for this one is it says it depreciates. The word depreciates means that it's going to be decay. So depreciates means it's decaying. So we're going to use y equals A times 1 minus r raised to x. Now, it's depreciating at 10%. So 10% is representing my rate. But remember, we can't do 10% in my formula. I've got to divide that by 100. So if I go in my calculator and I do 10 divided by 100, I get that my rate is going to be 0.01. Now, they want us to write the exponential model, and they want us to calculate how much the tractor is going to be worth in 7 years. So 7 years is going to be my input value. So let's start by writing the model. So this is going to be y equals, the initial value is 50,000. And we're going to say 1 minus. So 1 minus is the part of the decay formula. And then we're going to substitute in 0.1. Not the 10%. We're going to substitute the decimal value. And we're going to raise that to x for right now. And again, I can simplify this part, which is my base part. And I can calculate what that's going to be. So I'm going to say 1 minus 0.1. And I get that my base is now going to be 0.9. So I got 50,000 times 0.9. 0.9 is less than 1, so it is showing decay. And that's my model. All right, so now I want to use that model, and I'm going to substitute in for x to calculate how much this tractor is going to be worth after 7 years. So if the value of the tractor is going down, so if we started at 50,000, the value that we get should be less than that. So I'm going to say 50,000 times 0.9, and I'm going to raise that to 7. So the value of my tractor is now approximately worth $23,914, and we'll say about 85 cents.